Welcome back to the Deep Dive. This is the place where we look for those clever shortcuts to knowledge, the things that get you informed, but fast.
And our mission today is to dive into something kind of beautiful, actually. It's about how creative teaching can just totally transform a difficult subject.
Yeah, and we're looking at a very specific example from algebra. One of those formulas that everyone, and I mean everyone, dreads. We're talking about the square of the binomial.
But we're looking at how a specific approach turns it from this, abstract nightmare into a story you actually can't forget.
And our main source material for this is just fantastic. It comes from a Portuguese YouTube channel called CSI Matemática Cálculo sob investigação, which means calculation under investigation.
I love that name.
That's perfect, right? It's created by Sergio Machado. And if you've ever been stared down by a formula on a whiteboard, this is, well, it's like academic redemption.
It really is. So the concept we're tackling is one of the remarkable cases in math. A plus B to 2.
Ugh, I can feel the high school anxiety coming back just hearing it.
Right. Every student is just told, memorize the expansion. But rote learning, it fails. It's so easy to forget a piece. So we're going to see how this channel swaps out that dense formula for an actual plot.
Swapping a formula for a plot. That's a great way to put it. It really speaks to the part of our brain that wants a story, not a specification sheet.
Exactly.
Okay, so let's unpack this. Where does he even start? Because the title of the video itself sets a pretty different tone.
It really does. It's not Algebra 101. The title is Matemática Casos Notáveis Quadrado de Binomio, a notável historia de caso notável.
So the remarkable story of a remarkable case.
Yes. Right away, it tells you this isn't going to be a dry lecture. It's basically framing it as like mythology or a fairy tale.
So it's basically a Disney plot for a piece of high school math. That's kind of genius. And it starts just like one. It literally begins with once upon a time.
And he introduces our two main characters. And these characters, of course, are the two terms in the binomial.
So you have Princess Bai.
Representing the first term, A.
And Prince Nomial.
Representing the second term, B. It's so direct, you can't miss it.
And what's the first step in the algebra? It's their union. So the story goes, they came together in a binomial.
And right there, you have the structure. You have A plus B. It's not just two symbols, it's a couple.
Then the narrative takes that next step.
Yeah.
It gives the algebra a sort of relational meaning.
Yeah.
They decide to move in together.
Of course.
And they went to live in the squared house.
And that's it. That's your visual anchor for the whole operation. You're not just seeing a little number 2 floating over some parentheses. You're seeing a home, a structure, a place where things happen. And that structure, the squared house, dictates the rules.
And this use of anthropomorphism, I mean, giving human traits to variables.
Yeah.
That's so pedagogically brilliant, isn't it?
Oh, it's absolutely the core of why this works. Our brains are just fundamentally hardwired for stories and for characters.
Right.
The second you hear Princess Bai, you have a hook. AA is just an abstract symbol. Princess Bai is someone you can picture. It completely bypasses that feeling of information overload.
So that leads us right into what happens inside the squared house. This is the first result of them living together.
Yes. The story says, over time, she was squared.
So Princess Bai becomes AT22.
And so is he. Prince Nomial becomes P22.
So far, so good. That part feels intuitive. I think most students get that far. You square the group, so you square the individual.
Exactly. That's the easy part. It follows a very simple, if slightly flawed, logic.
But this is where it gets tricky. I can't tell you how many points I lost on tests for this.
Yeah.
The most common error is just stopping right there at $2 plus B22.
Everyone does it.
You forget that middle term, the 2OB dollar. Why is that? Why does that part feel so random and easy to forget when you're just learning the formula?
Well, because when you just look at A plus B22, your brain sees A and B. It doesn't immediately see the full distribution that's happening underneath.
You mean the whole A plus B times A plus B thing?
Exactly. When you multiply that all the way out, you get $2 plus AB plus B plus B to wow. Those two middle terms, O bigger B wow, are the same thing. You add them together, and that's where 2 at LA comes from.
But the formula just presents it as a fact. It feels like this magic ingredient that just appears out of nowhere if you don't do the long multiplication every time.
Yes, and that's the disconnect. It's a structural necessity of the math, but it's hidden. The CSI Matemática story, though, it makes it impossible to miss. It's not a calculation anymore.
It's an inevitable event in their lives.
It forces you to remember it. The story itself requires that you remember the consequence of them living together in that squared house.
And that consequence is the climax of the story. So After she was squared and he was squared, what happens?
They had children.
And the detail here is just perfect. It's stated so beautifully. It says,
Yeah.
they had 2 children, one just like their mother,
And the other just like their father.
and the story concludes, the binomial square was really a remarkable case. It just ties it all up.
It's the perfect resolution.
So now we get to the synthesis. Let's explicitly connect this whole fairy tale back to the identity. A plus B2 plus A2 plus 2AB plus B22.
Okay, so we have the binomial A plus B. That's the couple. Princess B and Prince Nomial.
Right. And the squared house is the exponent, the deal.
Then she gets squared A to 2, and he gets squared B to 2. So those are the first 2 terms that everyone remembers.
Which leaves us with the 2 children.
The 2 children.
Yeah.
The story is very specific. They had 2 children. One is a product of the mother.
And the other is a product of the father, B.
So a single child, their offspring, is the product of their union.
A bedable.
But the rule of the narrative, the rule of the squared house, is that there are 2 of them.
Exactly. The 2 children perfectly represent 2AB2 days. The story ensures you remember the 2.
That's the genius of it. You never forget to double that middle term because you can't just forget one of their kids. That would be terrible.
Precisely. It immediately explains why the formula has that middle term. It's not an arbitrary rule anymore. It's a logical, unavoidable part of a story that you now remember. So for you, the learner, this is the ultimate utility. You're not just doing rote memorization, which is brittle,
Very real.
You're linking this knowledge to a story. It engages your emotional memory, which makes it so much stronger, faster to access, and really reliable.
Think about the cognitive difference. If I ask you to recall the formula, you're using abstract memory. If you're stressed out during a test, poof, it can vanish.
Good there.
But if I ask you what happened to Princess Bai and Prince Nomial in the squared house, you're using narrative memory. That's way more robust. You'll tell me the story, and in doing so, you'll perfectly reconstruct the formula.
You don't just know the answer, you know the story behind the answer. It creates this really strong cognitive anchor.
And that ties right back to the channel's whole philosophy, calculo sub investigation.
Okay.
Calculation under investigation. It's treating a complex rule not as a wall to climb, but as a mystery to be solved.
A case to be cracked.
And the solution to this case is a charming cast of characters.
What's so amazing is that the creator, Sergio Machado, clearly understood that pure abstraction is what makes math so intimidating for so many people.
Yes, it feels rigid and cold.
But by adding humor, character, and plot, he makes the algebra almost secondary to just enjoying the story.
It's the ultimate Trojan horse for learning, isn't it? You think you're just listening to this quirky little tale, but what you're actually doing is embedding a fundamental mathematical identity that's going to serve you for the rest of your academic life. It proves that a complex topic doesn't always need a complex explanation.
It just needs clarity. It needs connection.
And narrative.
So this deep dive really shows the power of that. A simple, memorable story can embed these incredibly complex structures into something you can retrieve easily. It turns an intimidating formula into a charming memory.
And the value of this goes so far beyond algebra. It shows that even the subjects we think of as the most rigid, the most formal, the ones based on cold calculation,
Like calculation itself.
they benefit so much from investigation.
From storytelling. We started this looking for a knowledge shortcut, and it turns out the best shortcut involves replacing variables with princes and princesses. So what does this all mean for you as someone trying to learn something?
It really brings up a bigger question. If you can successfully teach the rules for squaring a binomial with a story about a princess, a prince, and a squared house,
Then what other complex subjects are we all struggling with right now? I'm thinking about things like, I don't know, the principles of quantum physics or counterintuitive ideas in economics or even complex chemical structures.
all those things that feel completely impenetrable.
Could they be unlocked with a simple, memorable story or analogy?
We have this assumption that to teach a formal subject, you have to use formal language. But this whole case proves that sometimes the most effective way to communicate is to use a little bit of, fictional drama to reinforce factual knowledge.
So think about how you could apply that principle of narrative. Is there some drive formula or abstract process you're trying to memorize right now that could be turned into a story?
Find your own Princess Bai and Prince Nomial for the next difficult concept you run into.
Use the story not just as an example, but as the actual underlying structure for the knowledge.
You'll be surprised how well it sticks.
We hope this gave you both a really useful tool for algebra and, maybe more importantly, A totally new way to think about how you learn and teach. Until next time, keep investigating.